Okay, so let's take a look at this one. On our shifted function, I want to go right 3, so it's going to be g of x equals, I see the x, I put a giant parentheses squared plus 1. What goes inside? Right 3 is minus, because it's on the inside, it's opposite, so then and that's it, you're done. You don't have to clean it up at all. Remember I said whenever you put something inside the square, you can't. I'll let you guys just leave that alone, because it gets complicated. And I'm going to go right 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, so that's this side. And then the other side, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3. And the other side. Like that. Something like that. My drawing's not really good, but that's kind of the idea. And then what are those points? Let's see. 3, 0, 4, 3, 1, my bad. 4, 2, was that 5, 5? Did you guys got?
5, yeah.
6, 10, or you might have gone the other way and gone 2, was it 2, 2, or you might have gone 1, 5, or you might have gone 0, 10. But you would have had 5 of those points, right?
Yeah.
Pick your points, whichever. Okay, and then the next one. We did this one already. We're going to take a look at the other one. See, the other one, how has this graph been shifted? It went, yeah, it went this way. This was the original one. So it went, but you can, if you went the other way, that's fine. It doesn't matter. If you read this one as being the original, that's fine. 1, 2, 3, 4. So it went 4, and I think it went to the right, but you could have said, this was original, went to the left, that's fine. Either way is okay. The reason is, pick a point and then say where it went to. So you could pick any one, probably not that one, because that one doesn't have it. Maybe you could have picked this point, this point, any one of those 3 points and said where it went to. Everybody follow me? So I'm picking this point, I'm saying that negative 2, 0 went to 2, 0. But you could have picked any one of those spots. Okay, great. So now we're going to take a look at our next handout. The one you guys just got, which is inverses. Yep. Okay. Intro to inverses. Shania, why don't you go and read for us? This part?
A recipe for creating a molded gelatin dessert states that just before serving the mold containing the gelatin dessert should be inverted onto a moistened plate in the mold removed. When you learn to divide one fraction by another fraction, you are taught to invert the divisor and multiply.
Right, so instead of dividing by this fraction, you multiply by its reciprocal. Right, you guys have seen that before. Right, the multiplicative inverse of a number, you guys remember that one? In other words, what you multiply by it to get 1. It's not 0, it's 1, right? Because any number multiplied by 1 is itself. So you find the inverse, you figure out what number you can multiply it to get 1. So 4/5 times 5/4 is 1. It's called reciprocal. It's also called the inverse. Multiplicative inverse. Next part. Alex, go ahead and read for me.
So,
So what?
So
do mathematicians mean when they talk about inverse? Actually, they can mean one of two things. One interpretation is the way inverse is used above, turning something upside down. Remember the exponent notation that is used to denote the reciprocal? The exponent of -1 can be used to denote the fraction 1/3. 1/3 equals 3 to the -1.
Yeah.
Thus, the multiplicative inverse of 3 is 3 to the -1.
Keep going.
But there's another meaning given to the word inverse in mathematics. When talking about a relation or function, the inverse of a relation or function is the relation or function that reverses it. If this sounds like a strange usage of the word inverse, look up the definition and you'll see how it fits.
Right, so the idea is an inverse kind of undoes something. So the inverse of multiplication is division. The inverse of addition is subtraction. Okay, so we're going to kind of look at some of those things here. I think we've talked about this before. But, yeah, thank you. So briefly. So you guys remember how do you use a function? If every input has only one output. It's a relation if you put in input, if you put in x, you can get two possible y's. If an x has two y's, then it's not a function, it's a relation. So here's the thing. The nice thing about it, if it's a function, if input has only one output, that's important. So for an inverse to also be a function, that means that every output could only have one input. Otherwise, the inverse would not be a function, right? It has to go both ways. I think we're going to actually. All right. So before we get to the, why am I reading this? Ryan, go and read.
Before we get to the how of finding and writing inverses, let's look at the why. Finding the inverse of a function or relation may seem like a rather unnecessary thing to do. However, there are real-world applications of inverses. You've actually used the notion of an inverse already in mathematics, you just didn't call it that.
Great. So who's ever been to a foreign country? So you go somewhere and you got to change your money into their money, right? And you got to change it back. So, for example, I want to go somewhere. I want to figure out how to translate, for example, 3 pounds 10 pence, 3.10 pounds to dollars. I would use a function. I pop that into my function and say spit out and tell me what this is in American dollars. And multiply it by some number and give me the American dollar amount. So back in 2015, the exchange rate of British pounds was roughly $1.50, right? $1.46751. So if you input, I don't know, it was something like say $14.67, 14.675 or 14.68 pounds. That would roughly cost me, if it was 10 pounds, it'd cost me roughly $14.68. So you drop it into this function, it spits out your amount in dollars. But say someone was coming from the United States to here, right? You meet a friend, you invite them to the United States, they need to do the opposite. They need to know if something's in dollars, how much is it going to cost in pounds? So the idea being this. Say I go to Mexico, and I think, well, I don't know what it is now, but it's roughly 1 to 20, right? So my dollar gets me 20 pesos. I go there, I exchange $100, I get 2,000 pesos. And say I don't use it at the end. So I drop in my $100, it spits out 2,000 pesos. Everyone on board? I come home, I need to exchange that money back. If I drop in 2,000 pesos, I should get back $100. Everybody on board? So if I start with whatever x I start with, if I drop it in the first function, it'll spit out some number, that amount. If I drop that into the inverse function, I should get back the x. I should get back what I started with. Everybody on board? Start with 100, put it in the first one, do the inverse, I should get back whatever, $100 or whatever is my beginning amount. So that's the thing about inverses, is that you do something and then the other one undoes it. Okay, that, I think we can skip the rest of that. That's the whole gist of all of that. So here are some things, some definitions, some things that are important. So here's some really nifty facts that you guys are going to love. Really, everybody loves this, right? Here's a nice thing. The order pair AB is on the graph of the relation. In other words, $100, or let's do simpler, $1, 20 pesos, right? 1 comma 20. Then on the inverse, the A and the B flip, because if I put in $1, I get out 20 pesos. In the inverse, 20 pesos is my input, $1 is my output. Is everybody with me on this one? So that means that 20 comma 1 will be a point on the inverse. Good? Also, the domain of the original function, dollars, becomes the output of the inverse. Right? So if I put in dollars on the original function, then I get pesos. Then the second function I put in pesos, my output should be dollars. So your domain of your original function is your range of the inverse. Everybody all right with this so far?
Yeah.
I'm going to get back to stuff that you guys are super familiar with.
Your x's and y's just flip, right? When you inverse.
Yeah, your x's and y's flip. They switch, they swap places.
Yeah.
Okay. Yeah, so this is exactly. Yeah. Right. Domains become the range, the range becomes the domain. Alright, so we're going to be looking at some stuff, kind of just to put it in perspective. So next page. Alright, so here's my first table. Grover goes to blue. Who's familiar with Grover? Sesame Street, yeah? Grover is blue. So the order pair is Grover, comma, blue. The next one I have is Cookie Monster. That's my friend's favorite. Cookie Monster is also blue. So Cookie Monster, comma, blue, that's another ordered pair. Is this a function, by the way?
Yeah.
Yes. You put in a monster, you're only going to get one answer. They're only one color. Everybody all right with that part? Good? Okay. So this is a function. Yes. Why? Each monster or character has only one color. Now, they're all monsters. So Big Bird is not a monster. He's a character. Right? Yeah, he is a big bird.
Isn't Grover green
Is it Grover what?
Green?
You're picking up the one that's in the trash can.
though? Oh, Oscar.
Oscar,
Oh,
yeah.
okay.
Yeah. So what's my domain? What's my inputs? Sesame Street characters. What's my output? What's my range?
Color?
Colors, yep. Good. Now, find the inverse. You're going to swap them. Put in blue, you get Grover. Blue, comma, Grover, right? The other one I had Cookie Monster blue, so it's blue Cookie Monster. You put in blue, you get Cookie Monster. Is this a function? No, because you pop in blue and say, hey, which Sesame Street character is blue? Well, some people are going to say, oh, Grover. Some people are going to say Cookie Monster. It has more than one answer. Do everyone follow me? More than one output. So this was a relation. goes with 2 characters. So since the domain and range switch when forming the inverse, what's the domain of the inverse? Colors, good. And what's my range of the inverse? Sets those 3 characters. Good. Right, you swap them. As you can see, the inverse of a function is not always a function. Right, because an x can have 2 y's. No, a x can't have 2 y's.
2 x's can have 1 y.
Yeah, thank you. 2 x's can have 1 y. Very well put. Perfect. Yeah. They saved me on that one. Thanks so much. All right. Exercises. Given table. Determine whether the table represents a function or relation. Justify your answer. Find your domain and range. List the components in each to list them. And then write a table for the inverse. Say whether or not the inverse represents a function or relation and say why. And then write down the domain and range of that. Okay, so I'll do the first one with you guys. Here's the table. Is it a function or relation?
Relation.
Relation. Why?
1945 is listed twice.
Yep. For it has
So
two,
1889.
has 2 outputs. Just pick one, doesn't matter. Just give one example of that fails and you're good to go. You can also say, yeah, 1889 has 2 outputs, either one. Okay, so my domain is going to be, and again, remember domains, you write a squiggly line, and you list them. 1845, 1889, squiggly line. What's my range? Okay, so do you guys all know your state abbreviations? Florida's FL, Montana's MT, Texas is TX, Washington is WA. Okay, so remember the every x becomes y, and I would say don't use the word flip, because if you use the word flip, a lot of times people they use it for the signs, so they make things negative instead of positive. Use the word swap, because swap means then you remember that you're swapping x and y. Does everyone see what I'm saying? So just get in the habit of using swap instead. That way you avoid that other mistake that people make of. So Montana, swap Montana and the year. Texas. And then write in your points. FL, 1845. Montana, 1849. Okay, so is this a function or a relation?
Function.
Function. Why?
Each state has 1 output.
Yep, each state has 1 date of statehood. They only became a state once. So my domain is going to be Florida, Montana, right? So again, my domain, my range becomes my domain becomes my range, right? Squiggly line. Everybody all right with this part? Take a picture if you need to. It will be in the board PDFs. And we'll do 1. In 5, 4, 3, 2.
Oh, wait.
Great, so now, which I guess I could have, you guys keep it. So you guys are going to do the next two, 2 and 3. So you guys are going to do this one, faculty members in the disciplines. So for example, Ms. Henson teaches math. Mrs. Woods teaches math. So think about whether, you know, exactly. What was that?
It's funny how it's on carbon.
Oh, is that a, oh, carbon, yeah, yeah,
She's a biology teacher.
she is. Okay, all right, so we're gonna do, you guys are gonna do those 2, 2 and 3, and then we'll come back. All right, so say maybe 5 to 10 minutes working on those.